Welcome to the first lecture of number systems. So, numbers are everywhere. We use numbers in everyday lives and we learn a lot about numbers. We use numbers for very much activities. We use number in everywhere, even in the mobile phones. So, everything is about numbers and everything revolves around numbers, which is around us. So, we are just digging a little bit deeper into number systems. First of all, let's go into number systems. So, digits, numbers, and numerals. So, what are these things? What are digits? What are numbers? What are numerals? So, first of all, the digits. These are the symbols. So, the symbol 0, 1, 2, 3, 4. And according to which system are we talking about here? We're talking about the Hindu Arabic system here. So the digits are the symbols like 0, 1, 2, 3, 4, whatever number we think of. We think of a digit 9, it's that. We think of a digit 1, it's that symbol itself is called a digit. And what is a number? So exactly this is the number 1, 2, 3, anything we write, everything are numbers. 4, 5, everything goes to numbers. So now we have two things called the value of digits. Actually, for example, think that we are taking a number 468. So there are two values for this number. The first value is the face value and the second one is the place value. So if we're taking this number, I think we would be similar, or we would know about the places. This is the ones place, this goes to the tens place, and this goes to the hundreds place. So the face value, or the value of the face value of 8, we are considering the face value of 8 and it is 8. If we are considering the face value of 6, it is 6. And if it's 4, it would be 4. So the value itself is called the face value. Now let's talk about the place value. So what is the value of the place which the number is in? So if we are taking the number 468, what is the value of the place? That is called the place value of that number. So 8 have a place value of 1, which is actually represented as 10 raised to 0. So 6 have a place value of 10, which is represented as 10 raised to 1. And 4 have a place value of 10 raised to 2, which is 100. So this is how we determine the place value of a number. So here I've given an example question where is to find the face value and the place value of 4, 2, 3, 3, 4, 7, 9, 0, 7. Actually, this question would be incomplete because we don't know whose face value to find. Because the face value of 7 is 7, 0 is 0, 9 is 9, 7 is again 7, 4 is 4, 3 is 3, and 4 is 4, like so and that. So we'll find the place value of these numbers. So first of all, the place value of 7 is 10 raised to 0, which is equal to 1. Place value of 0 is 10 raised to 1, which is 10. Place value of 9 is 10 raised to 2, which is 100. Place value of 7 is 10 raised to 3, which is equal to 1 with triple zeros, that is 1000. And it goes on 10 raised to 4, 10 raised to 5, 10 raised to 6, 10 raised to 7, okay, 7, okay, and 10 raised to 8. So these are the place values of this number 423347907. So yeah, this is a pretty huge number, it seems. So now we understood what is face value and what is place value. Now moving on, we are going to the types of numbers. Okay, we've heard about numbers. We've heard about a lot of numbers, like we know 0, 1, 2, 3, 4, 5. And it just changes how every people explain numbers. Because if you're going to a first or second grader and asking them what is the numbers, they'll just say that it's 1, 2, 3, 4. Oh, they'll say that it's 0, 1, 2, 3, 4, 5, 6. And it goes on. But if you're actually going to a student which is in a little bit of a high level of a class, they'll say that there are numbers like -1, -2, -3, -4, and so forth and so on. And if you go a further deep in, you'll get to know that there are numbers like √1, √2, √3. And again, it goes on where there are numbers called imaginary numbers where they have root of -1. So we're actually looking deeper into this. First of all, we are going to natural numbers. So what are natural numbers? Natural numbers are the numbers that we could count with our fingers, which is 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. So can we count 0 with our hand? Can we count 0 with our fingers? No. So natural numbers, we could say natural numbers, which is represented as n, is the counting numbers. So we could count it with our fingers. It goes on. So that's all about natural numbers. And now let's talk about whole numbers. What are whole numbers? Okay, so what are whole numbers? The whole numbers, as its name suggests, is the whole, which is we include 0 with the natural numbers. That if I'm putting natural numbers and 0, we will get whole numbers. So this is the basic thing about whole numbers. So we already know about two types of numbers. One is natural number and the second one is whole number. Now let's move on to the next type of number we have. Okay, next we have the integers. So what are integers? Okay, integers are a very beautiful concept where normally in the number line we have 0, we have 1, we have 2, we have 3, it goes on. And this number system says that there are negative numbers which are behind 0, which have the values lesser than 0, which is -1, -2, -3, and it goes on till -infinity. So these are called integers. So everybody maybe would get a question whether 0 is positive or negative. 0 is not positive, it's not negative. It's just 0. So that is about it. So now we know what is integers, which is denoted by I. We know what is natural numbers, we know what is whole numbers, and now we know what is integers. Okay, now we are talking about even numbers. We have all heard about even numbers. So what is even numbers? Any number. I'm taking a number 19. Is it odd or is it even? It's very easy to say that it's an odd number because 19 by 2 is not divisible completely. I mean, you could divide it, but you can't divide it completely. So if I'm taking 18, is 18 divisible on 2? Yeah, we get 9. So we get a number. So any number which is divisible by 2 is known as even numbers. So actually we get the opposite of it here called as odd numbers. So what are odd numbers? The 19 we talked about here, it's actually an odd number. Because why? It's not divisible by 2. So these are all about even and odd numbers. Now we have a little bit trickier number, which is called the prime numbers. So we all know about factors. So if you don't, let's just get back to what factors are. So if I'm factorizing 1, what is 1? 1 could be written as 1 into 1. So what is 2? Again, 2 could be written as 2 into 1. And 3, again it goes like 3 into 1. And what about 4 though? 4 can be written in two ways, which is 4 into 1 and 2 into 2. So what happens here is, we have two factors for 1 here. No, for 1 we have one factor, which is 1. We have no other factors. For 2, we have two factors, which is 2 itself and 1. For 3, we have the same situation going on. We have 3 and 1. But when it comes to 4, we have two factors for it, three factors for it, which is 4, 1 and 2. So any number which have more than two factors is called a composite number. So basically, when we are talking about prime numbers, the prime numbers would only have two factors. And which are these two factors? The two factors of a prime number would be that number itself and 1. So if we are talking about prime numbers, we will take 2 because 2 have 1 and 2 as their factor. We could talk 3, 3 have 1 and 3 as the factor and nothing else. 5 because 5 have 1 and 5 as the factor and nothing else. 7, again 1 into 7. 11 because 1 into 11 and 13, and it goes on. We could find it again and again by using the factorization method. Now the co-prime numbers or relatively prime numbers. Okay, so I'm taking in two numbers. So co-prime number is a set of two numbers. If I'm taking 5 and 8, are they co-prime or not? How are we going to check it? So we check the factors of 5, it's 1 into 5, and the factors of 8, which is 1 into 8, then 2 into 4. These are the factors of 8. So how many factors of these two numbers we have in common? We have 1 here and we've got 1 here. Other than that, there is no common factor here. So if the only common factor between two numbers is 1, we call them as co-prime numbers or relatively prime numbers. If I'm taking another example, if we are saying 3 and 9, these are not co-prime. Why? Because 3 is 1 into 3 and 9 is 3 into 3, also 1 into 9. We have 1 as a common factor and also we have 3 as a common factor. So we cannot say that it is a co-prime number. So again, taking another example, we could say 2 and 3. So what is 2? It's 1 into 2. 3 is 1 into 3. So again, we only have 1 as the common factor between them. So we can say that they are co-prime numbers. So what is composite number? The next thing we are studying about is composite numbers. Composite numbers is numbers like 4 we were talking about. Okay, 4 we're having factors 1, 2 and 4. It have more than two factors. It have more than two factors. That's why it's called a composite number. So we know what is prime number, we know what is co-prime number, and we know what is composite number right now. So let's move on. And now we have a bigger kind of numbers, that is rational numbers. So what is a rational number? A rational number is a number which can be expressed in the form of P by Q. What is P by Q? P by Q is a fraction. And we have a condition here, the Q should not be equal to 0. So for a fraction, we have a numerator and a denominator. Here P is the numerator and q is the denominator. So when we are talking about a fraction, we are considering a number, say 1 by 2. What is 1 by 2? It's 0.5. We actually get a number. Or we are taking 2 by 1. What is it? 2. So any number which is expressed as a fraction is called as rational numbers. So now we have irrational numbers. Irrational numbers are the numbers which cannot be expressed as a fraction. So let's say root 2. To be elaborate, I could say that 2 square equal to 4 and root of 4 equal to 2. This is the relation between square and square root, which we will come to later. So root 2 cannot be expressed as fractions. So this kind of numbers, we have pi, we have root numbers, anything which cannot be explained as a fraction or expressed as a fraction is called as irrational numbers. So now we have imaginary numbers. So what are imaginary numbers? This is getting interesting just because earlier I showed a number line where we had 0, 1, 2, 3, etc. And here we have -1, -2, -3, etc. So we always knew the root of all these numbers, root 1, root 2, root 3, root 4. We could always find the roots of these. But what about the negative roots? What should we say that root of -1 is? So we introduced a new term or a number called I or iota, which is equal to the root of -1. So iota or I is called as imaginary numbers. So we could say that 2i is root of -2. So this is about imaginary numbers. And now we have the real numbers. So the real numbers is the numbers, is the type of numbers which includes everything. Everything including rational, irrational, imaginary numbers, square roots, you name it, you have it inside real numbers. So to make it easier for you guys, we've got a diagram here. So first comes the natural numbers, which only have 1, 2, 3, etc. Now then we get into whole numbers. Actually, the whole numbers contain natural numbers. The whole number have 0, 1, 2, etc. And then we have the integers, which includes the negative numbers like -2, -1, 0, 1, 2. So again, this integers include the whole number and the whole number includes the natural number. And then we have rational numbers, which includes number like in any fraction form, like 0.1, which is denoted as 1 by 10. Anything which can be represented as a fraction is given under rational numbers. Integers can also be a rational number because integers, you could write it as what? -2 by 1 is -2. Again, it's a rational number. It is expressed in p by q form. Now, let's go on to irrational numbers. Irrational numbers like root 2, pi, etc., which are not expressed in the form of fractions, is there. And then we have imaginary numbers which have I. So all of these is included in real numbers. So from here, it's the end of the types of numbers. These are the types of numbers you have to know about. So now we move on to the properties of rational numbers. So we know that rational numbers are the numbers which can be expressed in p by q form or which can be expressed as a fraction. This actually can be of two types. which is a terminating number, a terminating rational number, and a non-terminating rational number. So what are these terminating and non-terminating rational numbers? So if we are talking about a case where there's a fraction 1 by 2, if we divide it, that is we divide 1 by 2, we get 0, 0, 1, we add a 0 here, we put a point here, 5 2s are 10, 0. We got the remainder 0, so the answer is 0.5 and it ends here. Now when we are looking into the non-terminating figures, we could see 1 by 3, like if I'm dividing 1 by 3, 0 3 is a 0, 1 comes down, and I'm adding a 0 and putting a point, so 3 3s are 9, again 1 balance, 0, 3, 9, 1, it just goes on, the 3 goes on here too, so it's not ending, it just goes on like 0.33333 and it just goes on. These are called non-terminating numbers. So leaving terminating and non-terminating numbers aside, let's go on to the properties of rational numbers. So the first property, first of all, what are properties? Okay, the number have some characters, like everybody have characters, so numbers should have some characters. There are some rules that the numbers follow. There are some rules when the numbers are operating will follow. If I'm adding two numbers, if I'm multiplying two numbers, if I'm subtracting two numbers, there are a set of rules or there are a set of properties which a number have. So first let's go on to the closure property. First we have the closure property. So the closure property is very simple. It just says that if A is a rational number and B is also a rational number, if I'm doing any operations on it, like if it's A plus B, A minus B, A into B, or A divided by B, we just get a rational number as a result. So adding, subtracting, multiplication, division would give me a rational number if I'm doing it to two rational numbers. It's pretty much basic. So now we have the commutative property. So what is commutative property? Commutative property just says this, that is A plus B is B plus A. Just a simple thing, which is if I'm saying 1 plus 2, which is equal to 3, it should be equal to 2 plus 1, which is equal to 3 again. This is what commutative property is saying. So again, in a multiplication way, if I'm saying 1 into 3, it gives 3, and if it's 3 into 1, it's also 3. Let's take a different example. Okay, I am giving it 4 into 3. 4 into 3 is 12, and again if I'm doing 3 into 4, it's again 12. So we are saying that either it's A plus B, it would be equal to B plus A, and A into B would be equal to B into A. Can we say this about subtraction though? No, we can't. Why? Because if I'm subtracting 1 from 2, what am I going to get? We get 1. What if I'm subtracting 2 from 1? We get minus 1. And these are not equal. So it's not commutative. Subtraction is not commutative and division is also not commutative. So there are two things which are commutative according to rational numbers, which is addition and multiplication. So in this property, using this property, we have some interesting things to go and look into. First of all, the thing is additive identity. So what is the additive identity of a number? The additive identity of a number says that if I'm adding a number to this thing, this additive identity, we get the same number. And what is that number? It's 0. That is, if I'm adding 0 to 2, we get 2. If I'm adding 3 to 0, we get 3. If I'm adding 478 to 0, we get 478. So adding a number to the additive identity gives the same number. So here the additive identity is 0. Now we have additive inverse. So what is additive inverse? So let's consider a number A. If I'm adding this additive inverse to this number, it should give me 0. So what is this number here? It should be the negative of the number given. So if I'm saying 1 plus negative 1, it would be equal to 0, and negative 1 is the additive inverse of 1. So if 2 plus negative 2 equals 0, which means that minus 2 is the additive inverse of 2, and also we can say that 2 is the additive inverse of minus 2, because when we sum it up, we get 0. Now let's go on to multiplicative identity. We know what is additive identity is. We know that if we add 0 to a number, we get the same number. So whatever operation you're doing to the number, you get that number itself as the product or the final answer. The number you're adding to it or the number you're multiplying to it is called the additive identity or the multiplicative identity. Not making it complex, let's go down. So first of all, a plus 0 equal to a. 0 is the additive identity. But what is a into a number equal to a? So what should be this number? It should be 1. So I'm saying 2 into 1 equal to 2. So multiplying 1 with any number gives me that number itself, and that is called the multiplicative identity. Now what is multiplicative inverse? Multiplicative inverse is also known as the reciprocal, which can be denoted as, if I'm taking the number as x, it could be x inverse or 1 by x or anything. So multiplicative inverse are these numbers when I'm multiplying a number. If I'm multiplying x with a number, I should get 1. 1 is the multiplicative identity. So if we multiply a number with a particular number which is called the multiplicative inverse, we get multiplicative identity which is 1. To make it simple, we're just saying that we need to get 1 as the answer and we have a number here. So what should we multiply it with? We should multiply it with 1 by x so that the x and x would cancel out and we get 1. So what is the multiplicative inverse of 2? The multiplicative inverse of 2 is 1 by 2, because 2 into 1 by 2 gives me 1. These are the things about commutative property which we are discussing right now. Now we have a few more properties, which is the associative property. So first of all, what is associative property? We are having three numbers like 1 plus 2 plus 3. So we always know that we add the things in the bracket first. So that is 3 plus 3, which is equal to 6. Now we are jumping on to a plus b plus c, which is 1 plus 2 plus 3, which goes like 1 plus 5, which is equal to 6. These both are equal. So what we are saying is, no matter how we are grouping the numbers, if we are adding it in different brackets, like if we are adding a number a to b and then we are adding it to c, it would be same as adding a to what is the sum of b plus c. This is the associative property. Now we have the distributive property, which is the last property we are talking about here. Distributive property is A into B plus C. That is, here we have a sum of two numbers and we are multiplying this A to the sum of these numbers. This would be equal to multiplying A with B and multiplying A with C. Let's take an example. If I'm saying 2 into 3 plus 4, we could do it in two ways. We could do it directly while saying that 2 into 3 plus 4 is 7, so which is 14. Or this would be same as saying 2 into 3 plus 2 into 4. So 2 into 3 is 6 and 2 into 4 is 8 and this gives us 14. So basically this is the distributive property of rational number. Now let's move on. So this is a quite interesting topic, which is rational number between any two rational numbers. So the interesting thing about numbers is that on the number chart, we write the numbers like 0, 1, 2, 3, it goes on. Here again, -1, -2, -3, -4, it goes on from here too. So what is in between 0 and 1? We could say that between 0 and 1, we have 0 0.1, 0 0.2, 0 0.3 until we reach 1. So again, when we are expanding, what is in between 0 0.1 and 0 0.2? We could say that it's 0 0.01, 0 0.02, and the scale actually goes on. So there are a lot of numbers, there are like infinite numbers in between two numbers, and that's the beauty of numbers. So there we are not going in this depth here. So we'll do there's a question saying find out the rational numbers between 1 by 10 and 8 by 10. So here we have fractions. Let me erase this. So we have fractions and we have to find the numbers between them. We were talking about rational numbers. So what are the rational numbers present in between them? If you are getting a question like this, it's pretty simple. These questions would be of two types. The first part is find out the rational number between 1 by 10 and 8 by 10. The second question is 1 by 8 and 3 by 5. What is basically the difference between them? This one have the same denominator. Whereas this one have a different denominator. So what do we do with the numbers with same denominator? If we say it's 1 by 10 and 8 by 10, we could say the numbers between them are 2 by 10, 3 by 10, 4 by 10, 5 by 10, 6 by 10, 7 by 10. These are the numbers between 1 by 10 and 8 by 10. But right now, how would we find the rational numbers between 1 by 8 and 3 by 5? Because we actually don't know, because these have the different denominators. Very simple thing, we are gonna make the denominators same, which is 1 by 8, we have 3 by 5. So we find a common factor between 8 and 5. There is no common factor between them. So we're just multiplying 8 with 5. When we multiply a number to the denominator, we do the same to the numerator and we get 5 by 40. And 3 by 5, we'll multiply both the denominator and the numerator with 8 because we have to find the common factor of 8 and 5. Now 3 8s are 24 and 5 8s are 40. Now we could find the numbers between 5 by 40 and 24 by 40. We could say any number like 6 by 40, or we could say 17 by 40. So this is how we find the numbers in between two rational numbers. So now we are moving on to simplification.